Hello class. Today we will continue our discussion of methods to separate mixtures. Last class we already had a brainstorm and you discovered 9 different ways to separate a mixture. And we discussed already filtration. Now I recall you, filtration is used to separate an insoluble solid from a liquid. Basically it is a funnel where we insert a filter paper. Here we have the representation of our filtration model. We have the residue, what is left behind the sticky rest, and we have a filter, and what is passing through the pores of the filter is called the filtrate. Now, the active principle is a difference in particle size. The two next techniques are called centrifugation and distillation. Centrifugation is a technique where we spin a sample of blood, for example, very fast round. What will happen is that the more dense materials will migrate to the bottom of our centrifugation tube. So here, for example, with blood at the bottom, we will find our red blood cells. At the top of our sample, we will find a serum. Here you see an example of a centrifuge. This is a big one. I recall the active principle is a difference in particle density. Next technique we will discuss is distillation. This is an excellent way for separating liquids from liquids or for solids from liquids. And it is based on different boiling points. Let's have a look at the basic setup. We need heat because we need to warm up our mixture. So here we have a distilling flask that contains a liquid, for example in this exercise, with a solid dissolved in it. Let's say water and salt. To control the process we need a thermometer. And to cool down the vapors that are produced while heating up, we need a condenser. This cools down our vapors so that they get liquid again. And we need, of course, a receiving flask, and what we will receive is pure liquid. So how does it work? We insert, for example, water and salt. We start heating, and when the temperature rises, for example around 90–100 degrees Celsius, the water boils. The vapors are trapped here in the tube, are condensed by the cooler device and get liquid again, and then will drop slowly here in the receiving flask. What we'll obtain is salt in the end here, the residue will be salt, and we will have our pure liquid here, water. You can immediately see a way of using it in desalination, and this conference is no surprise held in Tel Aviv in Israel. Guess why? Another way we use distillation is when we try to separate the different fractions of crude oil. Now crude oil consists of at least 50 different compounds. And to get these compounds separated, we heat the mixture at approximately 350 degrees Celsius, and then we push it into what we call a fractional column. In this fractional column we have different levels. Each level corresponds with a certain temperature. For example, the first level corresponds with 206 degrees Celsius. At this temperature, diesel will condense. At 180 degrees Celsius we will find kerosene that is used as a fuel for airplanes, and the higher we go, the lower our boiling point gets. At the top level we will have gases that even at room temperature will be gas. At the bottom we will find very heavy parts, very heavy residues, for example bitumen that is used for building roads. Now, please pass our exercise papers to your neighbors and start filling in the missing words. You have 1 minute to do this. Let's have a look at the correction. The first, the device to control the temperature of our mixture is called, yes, a thermometer. The device to cool down and to condense the vapors to water again is the condenser. The device in which we trap our liquid and our solid, so our mixture, is called the distilling flask. A distilling flask. And in the end, what we get is our pure water, a pure liquid. Thank you for your attention. I look forward to meet again to discuss the last 3 separation techniques with you together.